Good morning, students. We are going to continue the chapter number 2 with natural system of classification, which is given by Bentham and Hooker systems. So, according to Bentham and Hooker system, the division phanerogams are classified into three classes: dicotyledon, gymnospermy, and monocotyledons. So first we see the first class, that is the dicotyledon, is again classified into the three subclasses: polypetally, gamopetally, and monoclamidic or apetally. The polypetally is also again classified into three series: thalamiflory, disciflory, and caliciflory. Then thalamiflory again given 6 orders and 34 family in it. Disciflory also given 4 orders and 23 families. Caliciflory also includes 5 orders and 26 families. Then gamopetally again classified into the three series: inferi, heteromeri, and bicarpellity. Inferi series includes 3 orders and 9 families. Heteromeri includes 3 orders and 12 families, and bicarpellity includes 4 orders and 24 families. Then third subclass, that is the monoclamidae, directly having 8 series and 36 families. Then second class of phanerogams according to Bentham and Hooker system is monocotyledons, which is classified into the 7 series and 34 families directly. So this is the broad outline classification of natural system of classification, which is given by the Bentham and Hooker system. Then we must see that merits and demerits of these systems. So first we see the merits of these systems, that see here. First merit is a masterpiece work of 25 years of concentrated efforts on the systematic botany. Instead of replacing the systems, it must be elaborated. Second merit is that placing of Ranels at the beginning of systems is very reasonable. Third merit is the first natural system of classification. It is easy to follow and very useful for practical purposes. Next merits of the system is that through this system is not phylogenetic. Many arrangement in the systems match with recent phylogenetic systems. Example, that is the dicots are followed by monocots, which is correct from phylogenetic points of view, as monocots are evolved from dicots. Next, disciflory placed in between thalamiflory and caliciflory is very reasonable. Then next, system is based on careful first-hand information, and keys given are very useful. So these are the merits of these systems. Similar to the merits, there is also some limitations of this natural system of classification, and these limitations are such as: first is a great drawback of this system is a placing of gymnospermy in between dicots and monocots. Proper consideration is not given to the affinities among these groups. Second limits, that monoclamidae is not a well-defined group, families of which can be related to subclass polypetally and gamopetally. Third is sometimes Arbitrary characters are selected because of which closely related orders are widely spread or separated. Fourth one is that arrangement of monocots is unnatural. Example, Liliaceae and Amarlydaceae are set apart from each other on the basis of position of ovary. Otherwise, these two families are closely related. Fifth limitation is Orchidaceae and Cytaminae are considered primitive, while Cyperaceae and Gramineae more advanced, which is incorrect. And last limitation is some important floral characters are replaced, and it is based on the belief of fixity of species. So these are merits and limitations of these systems. Then after that we must see the third system of classification, that is phylogenetic system of classification, which is given by Engler and Prandtl. So according to this system, the division Embryophyta or Spinogamma are divided into two subdivisions, Gymnospermy and Angiospermy. The subdivision Angiospermy are again classified into the two classes, that is Monoclamidae and Dicotyledone. Monocotyledone is again includes 11 orders and 45 families. Dicotyledone also again classified into the two subclasses, Archiclamidae and Metaclamidae. The Archiclamidae subclass includes 30 orders and 186 families. Metaclamidae subclass includes 10 orders and 52 families. So the system which is given by Engler and Prandtl are also showing some limitations for these systems. First limitation is that Engler and Prandtl system considered of monocots are more primitive than dicots, which is not acceptable as per present knowledge. Third, second limitation is that the deviation bisexual from unisexual flowers is unsatisfactory. Third one is that the position of Amentiferae and Centrospermy at the beginning of dicots before ranales is unsatisfactory. Fourth one is that angiosperms have phylogenetic origin from an unknown hypothetical taxon of extinct gymnosperms. And last one limitation is that the acceptance of the derivatives of diclamidous flowers from monoclamidous ones is objectionable. So this is the third system of classification. Then after that there is the fourth system, which is included this year in new syllabus, that is APG systems of classification. So see here that the angiosperm phylogeny group or APG is an informal international group of systematic botanists who collaborates to establish a conscious on taxonomy of flowering plants that reflects new knowledge about plant relationship discovered through phylogenetic studies. According to these botanists, they have given APG systems into the 4 points. APG 1, which is given in 1998, APG 2, which is given in 2003, APG 3rd, which is given in 2009, and APG 4th is given 2016, which is important motivation for the groups was that they considered deficiencies in prior angiosperm classification since they were not based on monophyletic groups. So first we see the first APG which is given in 1998. The initial 1998 paper by the APG made angiosperms the first large group of organisms to be systematically reclassified primarily on the basis of genetic characters. The paper explained the author's view that there is a need for a classification system for angiosperms at the level of families, orders and above, but that existing classifications were outdated. The main reason why existing systems were rejected was because they were not phylogenetic, that is not based on the strictly monophyletic groups. An orderly classification of flowering plant families was proposed as a reference tool of broad utility. The broad approach adopted to define the limitation of orders resulted in the recognition of 40 orders compared to, for example, that is 232 in Takhtajan's in 1997 classification. Then we must see APG second, which is given in 2003. As the overall relationship between groups of flowering plants become clearer, the focus shifted to the family levels, in particular those families generally accepted in problematic. Again, coincidence was achieved relatively easily, resulting in an updating classification at that family levels. The second paper published by the APG in 2003 presented an update to the original classification of 1998. Then after that we must see the APG 3, which is given by 2009. The third paper from the APG updated the systems described in 2003 paper. The broad outline of this system remained unchanged, but the number of previously unplaced families and genera is significantly reduced. This requires the recognition of both new orders and new families compared to the previous classification. The number of orders goes up from 45 to 59. Only 10 families are not placed in an order, and only 2 of these are left entirely outside the classification. A major change in that the paper continues the use of families in favor of larger, more inclusive families. As a result, the APG third system contains only 415 families rather than 457 of APG second. For example, the Agave family or Agaveaceae and the family Thite are no longer recorded as distinct from the broader asparagus family. According to the authors, in APG first and second are likely to cause confusion, and that major herbaria which are rearranging their collections in accordance with the APG approach. This approach is being increasingly used in collaboration in herbaria and botanic gardens. Then fourth APG system, which is given 216, In this development of fourth version, there was some controversy over the methodology, and the development of consensus proved more difficult than in previous. Further progress was made by the use of large banks of genes, include those of plastic, mitochondrial and nuclear ribosomal origin. The broad outline of the system remains unchanged, but several new orders are included. Some new families are recognized, and some previously recognized families lumped due to the nomenclatural issues. The family's name is used instead of some families. That brings the total number of orders and families recognized in the APG system to 64 and 416 respectively. Two additional information major clades and that each comprise the additional orders that are included in the large clades dominated by the included APG3, APG4 also used the linear approaches. Okay, thank you.